if you remember from 5.1, ratios are just fractions. If we treat a ratio like a fraction, it is going to help us make equivalent ratios, simplify our ratios. So if we treat it like a fraction, it's going to make our lives a lot easier. And just like fractions, whatever we do to the numerator, you do to the denominator, not the denominators, denominator. So how do we get from 3 to 9? Well, if we times by 3 here, then we have to times by 3 here. So if we have a ratio of 3 blue marbles to 5 green ones, and we continue at that same ratio, we could also have 3 blue ones and 15 green ones, and we have that same ratio there. So an equivalent ratio is a ratio that is equal, right? 3/9 was the same, or 3/5 was the same as 9/15. Those are equivalent ratios. If we have a basic ratio, that is a ratio that is in simplest form. So instead of saying something like 3/9, I can divide them both by 3, and I can make it 1/3. 1 and 3 don't have a factor that can take it any smaller. Simplest form, just like simplifying a fraction. So our example here tells us that for every 4 cups of flour, you need 6 cups of sugar. So first we're going to double the ratio. So we're going to go flour to sugar. So flour and then sugar. So we need 4 cups of flour, 6 cups of sugar, and we want to double it. So we're going to times it by 2, times it by 2. 4 times 2 is 8. Do the same thing to the denominator. 6 times 2 is 12. So 4 6 and 8 12s are the same ratio. We made an equivalent ratio. Now we're going to simplify that ratio. So we're going to put our flour first, which was 4, and our sugar next, which was 6, right? I'm just writing it. I could write 4 to 6. I could say 4 to 6, but the easiest way is to treat it like a fraction. Now I simplify it. They can both be divided by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. 2 and 3, the only thing that goes into those is 1. So I'm in my simplest form, that simplest ratio. So we are going to be making equivalent ratios using tables. Tables can go horizontal across, or they can go vertical up and down and tell us that same information. So here's where our basic ratio is really going to come in handy here. So we know we have 4 and 6. So I'm asking myself, how did I get to 2? Well, I had to divide by 2. So I do the same thing here and divide by 2. 6 divided by 2 is 3. So here's my basic ratio. Once I have that basic ratio, I'm going to use my basic ratio to do everything else. How do I get from 3 to 12? 3, 6, 9, 12. I times by 4. So that means I'm going to do 2 times 4 to get here. 2, 4, 6, 8. Okay, I'm coming back to my basic ratio every time. Go back to the basic ratio. So I want you to make sure you write that down. Go back to the basic ratio. Okay, so now I have 18. So I'm asking myself, how did I get from 3 to 18? 3, 6, 9, 12, 15, 18. So I'm sorry, that was a poor hand choice. So you have 6 here. So this time I'm timesing by 6. So 2 times 6 is 12. Now this one I have on the top, so I have to ask myself, back from the basic, how do I get from 2 to 20? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that was 10 times. So 3 times 10 is 30. So all of these are equivalent ratios, but we wanted to use that basic ratio. So we simplified it first and then used our basic ratio to find the missing piece. Okay, so let's try that flour and sugar again with some different numbers. So we're going to divide to get smaller. We're going to divide by 2 is 2. So we're going to divide by 2 is 3. So here's our basic ratio. This is the one we want to go back to every time. So we're going from 3 to 9. 3, 6, 9. We're timesing by 3. So 2 times 3, 2, 4, 6. There we go. Hey, now we're going 2 to 10. 2, 4, 6, 8, 10. So there's 5 times. Now we're going to do times 5 on here. What we do to one side, we do to the other. Always going from our basic ratio. So 3 times 5 is 15. And now I have to go from 3 to 24. 3, 6, 9, 12, 15, 18, 21, 24. So 8 times. So I'm going to do 2 times 8 here is 16. So all of these equal 2/3. They're equivalent to each other, and 2/3 is our basic ratio. Always go back to the basics. Okay, we're going to use a basic ratio to identify an equivalent ratio. So here we can see, right, we took 12 and 3 and we said, oh, those can both be divided by 3. 12 divided by 3 is 4. 3 divided by 3 is 1. So now I have 9 and 6. 6 can't go into both of them. Neither can 5, neither can 4, but 3 can. So I'm dividing these by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. I can see these are not the same. 1 and 2, those can only be divided by 1. They're going to stay the same. 6 and 9, well, I already know 6 and 9 can be divided by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. This says 3 to 2. This says 2 to 3. These are opposites of each other. These are not equal. They're opposites. So let's try 8 and 2. So we're going to, can 2 go into them? Yes, it can. We're going to divide them both by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. So I can see these two are the same. They go in the same order. So that is Leslie and Nicole. So Leslie and Nicole went equivalent miles per hour. So again, we took it back to that simplest form. There's not a place for it. We just want to do that to be able to compare them. So that simplest form, that basic ratio, is really going to help us make sure we have equivalent fractions. Okay, a rate is a ratio that compares two different units. So before we've been comparing marbles, marbles, colors, colors, like they're the same thing. But now we're going to be comparing two different things. So here we're having 2 boxes of cereal cost $4. Boxes cost different ideas. Or the hamburgers cost this much money. I went this many miles per hour. So before we were making ratios of the same thing. Now we're going to be comparing 2 different things. So I want the ratio of boxes to the cost. So boxes first, cost second. So we have boxes. There are 2 boxes to $4. So my ratio is 2 to 4. 2 to 4, but I have to put boxes first, the cost second, because that's what the problem asked for. So same thing, it's still a ratio, but now we're just comparing different things than the same thing. So then we also can have a unit rate. So the unit rate is going to be how much is in 1. So how much 1 was. So some things you might hear, per unit. Unit means 1. If I have a unit of something, I have 1 thing. Unit, per 1, per hour, per day, per mile, right? That word per means how much is in 1 thing. So if 2 boxes of cereal cost $4, what is the cost of 1 box? we can set it up as a table, just like we learned about before. So the boxes, how many did I have? 2 boxes. Cost how much? $4. Now I want to know 1 box. Well, my boxes are on the top, so here's my 1. And I'm going to ask myself, how did I get from 2 to 1? Well, I had to divide by 2. 2 divided by 2 is 1. So I do the same thing here. 4 divided by 2 is 2. Every box cost $2, right? $2, $4. There's my 2 boxes. So we're doing that same thing. We wrote the ratio, but I need a label. This was my boxes. This is my cost. You can make the table. I usually just set them up like fractions. And here's 1 box. I need to know the cost of this one. So how did I go from here to here? Do the same thing here. We're creating equivalent fractions here. So go ahead and make sure your notes are finished. Sorry, this was a little longer one. There's a lot of stuff to go through, but you can do it.